Thanks for watching. If you enjoyed this video, please hit the subscribe button and ring the notification bell so you never miss an update. Leave a comment below to help grow the channel, and don't forget to smash the like button. Okay, welcome back. Lecture 3, Multiplication and Division, Facts and Patterns. So let's go through this. Probably the easiest pattern in multiplication that we can talk about is multiplication and division by 10. And in that case, it's really rather easy. We either add or take off a 0 at the end of the number. So for example, 3 times 10, we just rewrite the 3 and we add on a 0. So 3 times 10 is 30. And multiplication by 10 is just as easy as that. So why don't you try one at home now? Let's try 155 times 10. Go ahead and pause the video and give it a try. Okay, again, we just rewrite the number that we're multiplying by 10 and add a 0, and that's it. That's all there is to it. And division by 10 is just as easy. So when dividing by 10, we would simply take off a 0. You can kind of see how this would work here. If I divided 30 by 10, I'd get back to 3. If I added 1550 by 10, I'd get back to 155. That's because division is the inverse operation of multiplication. Just like subtraction was the inverse operation of addition, division is the inverse operation of multiplication. So let's try a problem. Let's try 80 divided by 10. 80 divided by 10. We just chop off the 0, leaving us with 8. And we can check our answer by simply multiplying 8 by 10, in which case we would add a 0 and we would get 80 back. Of course, you're probably wondering, what if the last digit is not a 0? Well, that means it's not divisible by 10 evenly. And we'll talk about divisibility in a later lesson. So let's try one at home. I would like you to try and divide 1,280 by 10. So go ahead and pause the video now and try it yourself. Okay. Again, we just chop off the 0 at the end of the number. So 1,280 becomes 128. It doesn't get any easier than multiplying and dividing by 10. Probably the next closest thing would be multiplying and dividing by 2. So let's try that next. Before doing that, however, before I show you the procedure that we're going to do, I should mention that this is what you would more or less think of as mental math. It's the math that you do in your head. There's nothing really to write down. And when we do mental math, it's always, or usually, it's more convenient to, instead of working from right to left like we did with addition and subtraction, to work from left to right. And you'll kind of see why that is as I go through the procedure here. But there are a few multiplication facts that you need to, commit to memory before proceeding for multiplying by 2, also known as doubling. So let me write down these facts. The first fact is 0 times 2 is equal to 0. 1 times 2 is equal to 2. 2 times 2 is equal to 4. 3 times 2 is equal to 6. And 4 times 2 is equal to 8. Now, that gets us up 0 to 4. What about 5, 6, 7, 8, and 9? Well, let's try an easy example first, something that's not too hard to double, that only involves these multiplication facts here. Let's try 243 times 2. You're thinking, wow, that's an awfully big thing to have to multiply, but it turns out it's really easy because when we double things, we can do it digit by digit, starting from the left, going to the right. So the double of 2 is 4. The double of 4 is 8. The double of 3 is 6. Therefore, 243 times 2 is 486. We just double each digit one at a time. Again, left to right is the best way to do this. And normally you would kind of do this in your head. If you want to just write down each digit as you go through, so you want to double the 2, write down the 4, double the 4, write down the 8, double the 3, write down the 6, that's fine. All right, now that we see how to double a simple number, let you try one at home. I would like you to double 3,341. So go ahead and pause the video and try that now. Okay. Again, just doing it digit by digit. start with a 3. That's going to give us a 6. Double of 3 is 6. Again, we have another 3, so double it. Another 6. 4, we double it, we get an 8. 1, we double it, we get a 2. Therefore, our answer is 6,682. Okay. Now, what about the other single-digit numbers that might get doubled or multiplied by 2? Because certainly we might encounter a number that we'd like to double that is bigger, that has a digit that's bigger than, 4. So let's see how we handle that. And this can be a little bit tricky to do at first, but I think after you practice it a little bit, you'll find it pretty easy to do. But first, let me note, if we wanted to look at 5 times 2, of course, many of you probably know that's 10. But with this procedure, we only keep the ones place. That's the only thing we're interested in, is what's in the ones place. And the ones place of 10 is, of course, 0. And for that reason, it turns out that 5 times 2, 6 times 2, 7 times 2, all of these can be thought of instead of, since we're only going to use the ones place of the products for 5 times 2, which is 10, 6 times 2, which is 12, 7 times 2, which is 14, 8 times 2, which is 16, and 9 times 2, which is 18, you see that the ones place is exactly the same as the numbers above. 0 for 10, 2 for 12, 4 for 14, 6 for 16, and 8 for 18. And the way that you can think about it is that 5, the 5's conjugate of 5 is 0, and 0 times 2 is 0. The 5's conjugate of 6 is 1, and 1 times 2 is 2. The 5's conjugate of 7 is 2, and 2 times 2 is 4. The 5's conjugate of 8 is 3, and 3 times 2 is 6. And the 5's conjugate of 9 is 4, and 4 times 2 is 8. And so we can just use the 5's conjugate as a guide to these. So all we have to do is memorize these 5 multiplication facts, and we're good. And if you're unfamiliar with the 5's conjugate, then you go back to lecture 1 and you learn everything you need to learn about it there. Okay, so let's have a look at how we would use this. Let's try 45 times 2. So we're going to double 45. So how do we do this? Well, we double the 4 to get 8, but there's a catch. We look at our neighbor to the right, we see that it's a 5, right? That means that when we get to that one, we're going to treat 5 times 2 as just 0. So we have to somehow deal with what we would have as a carry if we were doing standard multiplication. So any time our neighbor to the right is 5 or more, we add 1 to this digit. So 4 times 2, the double of 4 is 8, so we add 1 more and get 9. So the first digit here is 9, and then 5 times 2 is just 0. And 45 times 2 is 90. Let's try one more. How about 83 times 2? 83 times 2. Now this time, something interesting has happened. The first digit is 5 or more. And what do we do then? Well, in that case, we just make, so we might say, well, 8 times 3, you said just keep the ones place, right? And so 8 is the same thing as 3 times 2. So 3 times 2 is 6. So should we just write down 6? And the answer is no. So instead what we do is we make it a teen, right? So that's going to be 1, 6, or 16. And then we proceed as normal. Double the 3 to get 6. So 83 times 2 is 166. Now let's try one at home. I would like you to try 8,496 times 2. Go ahead and pause the video and try that now. Okay, well, starting from the left, because remember we're working left to right when we do this. The double of 8, well, we did that in the previous example, right? We know that it's 6, but it needs to be a teen since it's the first digit. So we write down 16. Do we have a big neighbor? No, we don't, so we can just write 16. Then we double the 4, we get 8. But we have a big neighbor, so we need to add 1 more to it, making it 9. We double 9, the same thing as doubling 4, because the 5's conjugate of 9 is 4, and that gives us an 8. Do we have a big neighbor? Yes, we do, so we add 1 more, another 9. Finally, we double a 6 to get 2, and we just write that down as 2, because there are no more neighbors to consider. And so the double of 8,496 is 16,992. Okay, now that we've dealt with multiplication by 2, let's do division by 2. It's a little bit different, but I think you'll find it pleasant. So we can, since we remember these multiplication facts, then we certainly know what 0 divided by 2 is. That's going to be 0. We know what 2 divided by 2 is. That's going to be 1. We know what 4 divided by 2 is. That's going to be 2. 6 divided by 2 will be 3. And 8 divided by 2 will be 4. That's because, again, division is the inverse operation of multiplication. So it kind of works backwards, right? So if we're going to half a number, we can just half it one digit at a time. So 42 divided by 2. Let's try that one. 42 divided by 2. So what is half of 4? Well, using our multiplication facts, right, half of 4 would be 2. So we write down 2. What about 2? What is half of 2? Well, again, using our multiplication facts up here, half of 2 is 1. So half of 42 is 21. Let me give you one to try. Let's try 826 divided by 2. Go ahead and pause the video and try that now. Okay, starting from the left, digit by digit, half of 8 is 4, half of 2 is 1, and half of 6 is 3. So 826 divided by 2 is 413. Now, notice that we can always go back and check our answers by doubling these numbers. Double of 21, well, that doubles to 4, that doubles to 2, 42. We can double this one, the double of 4 is 8, the double of 1 is 2, the double of 3 is 6, so it checks out. But notice that none of these numbers, when we double them, would have had a carry. So let's change that, and instead of doing 21, let's try 26, because what's the double of 26? Well, we would double the 2 to get 4, but we have a big neighbor, so we add one more. So that would make it 5. And then finally we would double the 6 to get 2, and we would get 52. So let's try and divide 52 by 2, because we know what the answer is. 52 divided by 2. We know what the answer is because we just concocted it, so it's going to be 26. So somehow I have to take half of 5 to get 2. So the trick here is whenever you have an odd number digit, treat it like the next lowest even number. In this case, treat a 5 like it's a 4. A 1 would be a 0, a 2 would be, or a 3 would be a 2, a 5 would be a 4, a 7 would be a 6, a 9 would be an 8, and that's all the digits we have. So half of 5, we're going to treat it like half of 4, that's 2. And just write down 2. Then we get to this step, the next digit over. Half of 2, of course, is 1. But to pay the cost, I don't like the size of this 2. I wrote everything big. Let me write this big as well. Because of the trick that we did here by treating 5 as if it were 4, when I try to half 2 and get 1, that's going to give me the wrong answer, because that would give me the same answer as 42 divided by 2. So the way to deal with this is, after we half this, half of 2 is 1, now we take the 5's conjugate. The 5's conjugate of 2 is 6. We write down a 6, and that's our answer. Now, the reason why that works, I could demonstrate it algebraically, but we haven't learned algebra yet, so I'm not going to do that. So you'll just have to trust me that it does work. Let's have you try one now. Let's do 156 divided by 2. 156 divided by 2. Go ahead and try that at home. Pause the video. Well, our first digit is odd, so we have to treat it like the next lowest even number. The next lowest even number is 0, and half of 0 is 0. So, but leading zeros we don't need to write, so I'm not going to write the 0 down. We just move on to the next digit. Now we take half of 5. Well, 5 is odd, and so we're going to treat it like a 4, and half of 4, of course, is 2. But we do have an odd left neighbor, which means that we have to take the 5's conjugate of 2 to get 7. Moving on, half of 6 is 3, but it too has an odd left neighbor, the 5, and so we have to take the 5's conjugate of 3 to get 8. And so we get our answer that half of 156 is 78. We can take what we learned about multiplying by 2 and dividing by 2 and apply that to multiples of 2, like 4 and 8 and 16 if you wanted to. So since 4 is 2 times 2, that's 2 2's, then if we want to multiply a number by 4, we just have to double twice. So let's just look at an example of that. What if I wanted to double or multiply 21 times 4? Well, I could double it one time. The double of 21 is 42, and that's going to be 42 times 2. So I take one of the 2's off of the 4 here, because I've already doubled it once, and I can double it a second time to get the final answer. 42 times 2, the double of 42 is 84. Similarly, I could multiply something times 8. So what if I want to multiply 21 times 8? Well, I already did it a few times, or 2 times here, the doubling. So I could double it one more time, 84 times 2, and then double this. That's going to give me 168. So 21 times 8 is 168. So you can take advantage of that, and you can do the same thing with division too. Instead of dividing something by 4, you can divide it by 2 and then divide it by 2 again. If you wanted to divide something by 8, just divide it by 2, divide it by 2 again, and then finally one more time, divide it by 2. Wouldn't it be nice if you could just look at an arithmetic problem and know the answer? Wouldn't it be nice if it was as easy as reading off the digits? Wouldn't it be nice if large numbers were no more difficult than small numbers? They just take a little longer to rattle off the answer. This is exactly what the method in digit-by-digit arithmetic achieves. For example, you can multiply by 5 by simply reading off half of each digit from left to right and adding on a 0 when you're done. For 2 times 5, you would simply say 10 because half of 20 is 10. Digit-by-digit arithmetic, fast math to minimize working memory strain. All right, next I want to think about multiplying numbers by 5. Now 5 has a nice trick. Again, it's not that hard to figure out why it works. It's easy to show algebraically, but I'll just have you take my word for it. So multiplying numbers by 5. The trick is to first multiply it times 10 and then half it, because 10 is 5 times 2. That's the double of 5. So if we want to multiply a number by 5, we can simply multiply it by 10 and then half that number. So let's try 24 times 5. 24 times 5. If I multiply this times 10, I get 240. And then I need to divide that by 2 to get my final answer for 24 times 5. Half of 240, well, half of 2 is 1, half of 4 is 2, half of 0 is 0. So 24 times 5 is 120. Now you can do this all in like one step, or you can do the 2 steps separately. Let's let you try one at home, see how it goes. 16 times 5. Go ahead and pause the video, give it a try, and come back when you've got it. Okay, 16 times 5. So first step, we need to multiply 16 times 10. That just means we add a 0 to the end of it. So that's 160. And then we're going to half that. So we're going to take half of 160. Half of 1 is 0, but I'm not going to write the leading 0. Half of 6 is 3, but I have an odd left neighbor, so I'm going to make it 8. Alternatively, you could just think, well, if I know what half of 16 is, it's 8, then I could just simply write that 8 down for this part. And then half of 0 is 0, no odd left neighbor, so it just stays 0. So 16 times 5 is 80. Now dividing by 5, it's a very similar procedure. So instead of multiplying times 10 and then taking half, or dividing by 2, instead we do the inverse of that. So we double the number and then we divide it by 10. So let's have a look at how that works. It's just the same procedure as multiplying by 5, but exactly backwards. So let's do 125 divided by 5. So first we will double it. So if we double 125, we're going to get the double of 1 is 2, the double of 2 is 4, but we have a big neighbor, so we'll add one more, making it 5, and then the double of 5 is 0. I mean, it's 10, but we only keep the 0 when we do it this way. So we have 250, and we're going to divide this by 10, which means we're just going to chop off the 0. And so we get 25 as our answer. So 125 divided by 5 is 25. Now let me give you one to try at home. Try 625 divided by 5. Pause the video and return when you have the answer. Okay, so first step with dividing by 5 is we double the number. So we double the 6 to get 12. Remember, if our leading digit is 5 or more, we'll make it a teen. So we'll put a 1 followed by the double of the 5's conjugate of 6 is 1, so we double 1 to get 2. Then move on to the next digit. The double of 2 is 4, but we have a big neighbor, so it'll become 5. And then we double the 5 to get 0. Then we have to divide by 10, which means just chopping off this 0. That's why I think it's best to do it all in one step, because whatever you get, you're going to chop off the 0 at the end. So we get 125. Okay, so those are the only kind of fast mental math techniques and patterns that I'm going to reveal. There's only one other thing I'm going to mention, and that is nines. Though this is not a digit-by-digit multiplication technique, but it's an observation that we'll talk about later when we talk about divisibility. But it makes it easy for multiplying numbers times 9. So the trick to remember is that if when I multiply a number times 9, like say 4 times 9. And this is true for all of the single-digit numbers times 9, up to 9 times 9. What you can do is, the trick is, first take this number and reduce it by 1. So 4 minus 1 is just 3, so write down a 3. Now, the remaining part of the answer is only one more digit, and the trick to figure out what that digit is that numbers that are multiples of 9 always have their digits add up to 9. So what number do I have to add to 9 to get, or to add to 3 to get 9? That would be 6. So 6 plus 3 is 9, and so 4 times 9 is 36. So reduce this number by 1. That's the first term, and then add to that, the second term will always be whatever I need to add to this number to get 9. So you try one at home and I think you'll get the hang of it. I want you to try 8 times 9. Pause the video, come back when you've got it. Okay, 8 times 9. Well, 1 less than 8 is 7, so it'll be some number of 70. And I asked, what do I have to add to 7 to get 9? And that, of course, is 2. And so 8 times 9 is 72. Multiplying numbers by 3, by 6, 7. There's no really easy way to do it, like with doubling. So for those, I recommend just using flashcards and memorizing these multiplication facts. For the lectures that come after this, really you only need to know the single-digit multiplication facts, because when we do multiplication problems going forward, it'll always be, we're going to work from a point of view where we take a single digit times another single digit. So for the purposes of moving on to the next lecture, make sure you have your multiplication facts up to 9 times 9. And that's what we'll do next time. We'll talk about long-form multiplication. Till then, thanks for watching.